Hello everyone. Thank you all for joining and welcome to the Women in Data Science Conference, Miami. My name is Shailvi Wakhlu. My keynote today will be a journey to explore bad data. Together we will understand how to prevent bad data, diagnose it, and how to cure it. By the end of the talk, I hope you feel empowered with the right tools to make sure that bad data never gets in the way of great business outcomes. A little bit about me. I go by the she, her pronouns, and I live in San Francisco. I work at Strava, where I am their Senior Director of Data. Strava is the leading social platform for athletes and the largest sports community in the world, with over 80 million athletes in 195 countries. Let's kick off our main topic for today and start by answering the question, what is bad data? Bad data is any data that is inaccurate, incomplete, or misleading. Such data can also be referred to as low-quality data and can show up in many different forms. All of it can lead to bad decisions. Just to be clear about what bad data isn't, data that shows you something that you don't like seeing or something that you don't want to see, that doesn't make it bad. If the data is accurate, complete, and isn't misleading, it isn't bad data. A few common examples to illustrate how you might notice bad data. I will take the example of you looking through a few trusty dashboards that you rely on to make decisions. First, you check a dashboard to check the total number of sales for your product last month. The dashboard says you had 2 million signups, while the sales team has recently been celebrating hitting 2.5 million sales last month. Which one is it? One of those two pieces of data is inaccurate. Next, you check the dashboard that identifies the number of sales broken down by country. Here also you notice something peculiar. You know your product is mostly being marketed in North America, so it makes sense that Canada and Mexico show high number of sales while European and Asian countries are not as big. But it feels suspicious that USA is such a small number in comparison to Canada and Mexico. Your product is, after all, primarily made and sold in America. So you know intuitively that USA should have a much larger number of sales. Something is going on and your data is probably incomplete. And finally, you check the graph that shows you your year-on-year revenue growth rate. Here it looks like you have something to celebrate. Your revenue went up by 4%. But wait, intuitively, that also feels less to you, as you know your company has heavily invested in marketing your product, and 4% seems less in comparison. Based on the previous two learnings about inaccurate and incomplete data, you are now pretty sure this data is misleading you into believing your growth is small while it is actually much larger. In all of these cases, you are noticing something that doesn't make logical sense, and they all probably have the same root cause. The differences you are observing are meaningful, and if they're not resolved, you and your company might end up making bad decisions. Hey, if it turns out that you made $500,000 extra in sales, your company might decide to celebrate that with a fancy party rather than cookies in the kitchen. So this is very important to figure out. Besides a party versus cookies decision, why else should we care about bad data? Bad data can be costly in many different ways, and unfortunately, the more widespread it is, the worse it gets. First thing it does is lower trust. If bad data went unnoticed or unchallenged and got presented out to someone who later learns that the initial data presented to them was incorrect, it can be very damaging to your reputation. Depending on who you presented the data to, whether it was your peers, your boss, your leadership team, company investors, or worse, the mass public, there can be a lot of consequences with that lowered trust that are expensive to fix. You could also directly lose real money right away through either lost revenue or just losing out on opportunities because data led you down a different path. There could also be direct costs to fixing the bad data issues that show up as extra expenditures. A big cost is harm to real people through bias. If your bad data incorporates hidden biases, they cause harm to people, and that is a real cost and not just monetarily. In some cases, you or your company can be held liable depending on what data it was that went wrong, why it went wrong, and what outcomes resulted from the fact that it was incorrect. And lastly, bad data is time consuming and painful to fix, and that is a productivity cost to your data scientist and also a big hit to their morale. Data scientists, unfortunately, can end up spending a lot of time on fixing bad data. First, they find an error or someone brings it to their attention, and they have to spend time understanding what's going on. Then they have to communicate the error to concerned parties, especially if it might take some time to fix and if it would be important to stop any decisions that are taken on the basis of the data in the meantime. Then they have to hunt for the cause of the bad data and pinpoint the source it is coming from. Then they have to validate and cross-check the source and QA it to make sure they can find the discrepancy. After that, they have to institute an actual fix that will correct the problem while also ensuring all downstream errors are fixed. Confirming that the data is indeed fixed and that there are guardrails put in place to prevent this from happening again is very important at this stage. And finally, they have to again communicate the fix, even if the fault wasn't caused by them, explain everything to ensure that people still trust them and the data. All of this can be very tiring and feel like an additional burden that data scientists have to carry. People ultimately leave jobs because their talents are not utilized optimally, especially if the company doesn't make the space and time to address the bad data. So now, what can we actually do about bad data? We can prevent it, diagnose it, and cure it. I'm going to spend a bulk of our time today at the prevent stage. I truly believe that understanding prevention of bad data is the best way to also get better at diagnosing and curing it. Let's dive in and understand the prevent stage and see how bad data gets introduced.
Up first, a close look at the life cycle of data. All data goes through similar phases in a sequential manner. First, we define the features and align the different teams on the definitions. Next, we work on logging the data to track and store it. After that, we use some business rules to transform the data into a usable format. Then, an analyst is able to interpret the data to solve some business problems. And finally, the data results are shared with the stakeholders. And that wraps up the data lifecycle. Next, once we have identified the data lifecycle, you'll start to see that at each phase, there are numerous possibilities where you can unintentionally introduce some bad data. There's a lot going on with this graphic, but I wanted to show the full picture before I dive into each of the sections. I usually have this graphic pinned somewhere to remind me of all the places where my data might get corrupted. Let me jump into each of the sections before I come back to this visual. A lot of my examples today will be anchored at the COVID-19 pandemic, since unfortunately, that is the theme of the world that we live in right now. But I know things are starting to look up with the vaccines, so I hope next year we can have some other fun anchoring. Let's say you are trying to track COVID cases in a population. You are relying on data filled out per patient by healthcare workers. How do you define the various pieces of data that you need to track? A lot of issues can arise based on how specific or flexible that definition is. Your feature definitions may outline that a diagnosis for COVID means they count as a positive case. But what about people who were asymptomatic and never received a formal diagnosis? They might still test positive for antibodies, which means that they did have the disease at some point. But should that trigger a case flag? Now, COVID, as we understand, is a widely reported and well talked about disease. So you may end up deciding one way or the other about how to deal with these cases. But it might end up being super inconsistent with the way the caseload criteria is used for other diseases. And that might mean that you are using uneven logic, which might eventually lead to the creation of bad data. You can also sometimes have a very narrow definition that just doesn't include all the scenarios. You pick a definition that fits today's use case, but don't account for tomorrow. That may also cause problems when you catch up with the pitfalls of that narrow vision and spend time fixing it. That's the case that we are seeing with the different variations of COVID-19 and the different variants. Sometimes it's just plain old human error. Maybe your definition logic is correct, but a typo causes a different disease with a few letters here and there to be picked up in the case statements. These kind of errors are actually relatively common, unfortunately. Even a bad definition causes you to miss seeing a clear picture. Your picture may be blurry or oddly cropped out, or just not the picture of what you wanted to see in the first place. Next is the logging stage, where you actually track the features you have defined. There's a lot of potential for confusion and inaccuracy at this stage. Your tracking could be incorrect. Perhaps the engineering team is only logging a subset of the information or is logging the wrong information. You were expecting all COVID patients to be tracked, and instead you only have COVID patients who have insurance because you're relying on insurance companies to gather your data. Maybe you're actually logging all cases for patients with or without insurance, but you're just logging them at separate places. This will make it very hard for you to reconcile all this information later, especially if you don't know if there are unintended duplicates. Example, people who showed up in both data sets because they didn't realize they were covered by insurance when they first came for treatment and later got reimbursed. Or your pipeline itself could be faulty. Maybe there are exceptions where it just doesn't track the data. For example, the healthcare worker is using their mobile app to fill out the case details, and that tracking is misaligned with the web tracking of that same app. Or the pipeline is broken and that you didn't notice. In some of those cases, you may have no way to retrieve the data again. Another common problem is time frame issues. How long is your data being stored for? When does it get aggregated? What time zones are being used? All of these and a misalignment in any of this information can eventually cause problems. Ultimately, if the connection is broken between the data that you want and the data that you actually are tracking, then you're going to end up with a lot of unintended consequences. Just like baking, if you are taking a bunch of rules and transforming raw ingredients to a finished product, there's a lot of mistakes that can occur along the way. With data, you need to take that raw data and convert it to something usable. Otherwise, every baker will create their own recipe and make a different product. First part of that is making sure that the rules are clearly understood. When two humans look at a piece of data, they might make very different assumptions about why it's there and what it represents. You see the cake in front of you, but you're unlikely to know exactly what recipe was used and what ingredients it contains, and you'll just try to take your best guess. Similarly, when someone wants a table to contain per day the number of COVID cases, without more context, they really don't know if that table represents new cases, cumulative cases, or just all current cases where someone is diagnosed and hasn't yet recovered. Depending on what assumptions they make, that data can be used very differently downstream, unless everybody uses the same policies for labeling data. Data dictionaries can really help in this regard. How data is aggregated can also impact how useful it is. If your data is not incrementally aggregated, you may need to go several steps up in the pipeline to figure out what is the raw data that you actually need. Or you end up jumping through a lot of hoops trying to use the aggregated data for your specific purpose. Either ways, being thoughtful and aligned with the aggregations and the specific use case can save you from a lot of data gymnastics at a later stage. Finally, you can have logical errors while transforming. Human error shows up in almost every part of the data lifecycle, and transformation is no exception. We're on to our fourth stage of the data lifecycle, which is analyzing. This is where the rubber meets the road and you start actively using the data as an input for key decisions. First step is the problem statement itself. Stakeholders and analysts can easily be misaligned on the question that they're trying to answer. if they have not resolved that early on. The misalignment can lead to assumptions that are expensive to fix once the analysis has already made significant progress. The rework and the resentment that follows can all be avoided if there is clarity about what problem is being solved and what the various nuances mean. Besides that, while analyzing results, there is always a capacity for human error. If you maybe perhaps use the wrong model to solve your problems, or you just make mistakes in your calculation. The last thing to watch out for is bias in your algorithm. This honestly is a pretty large topic on its own and is a whole talk. The consequences of getting things wrong can be intense, especially in more sensitive industries like healthcare. You have the capacity to negatively affect the disease burden of entire populations if your algorithm is biased. If you used a biased data set to learn about how a disease progresses, and it only includes data points from a specific demographic, your published insights can actively cause harm to the underrepresented demographic that were not included in your original data set. Unfortunately, there are some pretty blatant examples of this in the industry. For example, women were more likely to die from a heart attack because their symptoms were different from those of men. And that led to a poorer diagnosis because those data points were not available. Those early heart attack studies did not include women, which meant that their symptoms were just not widely understood. Similarly, there are differences along race, which led Black women to have a higher pregnancy-related mortality rate due to systemic racism that provided inadequate and inferior care. Here again, the lack of data and research that quantified the problem led to this issue being ignored for decades, because Black women dying during childbirth was something that was not seen and tracked in the aggregate, so it was not addressed. Essentially, there is a lot of thoughtfulness required to make sense of the data and extract the right insights at the analysis stage and not to make an unintentional error. Lots of folks may be tempted to treat an incidence of breast cancer in men as just bad data and remove it from their analysis. But depending on the situation, even though men have it at low rates, it may still be relevant to your analysis. You may otherwise be unintentionally throwing out useful data for transgender patients who are also historically underrepresented in optimized healthcare outcomes that serve their unique needs. And now to the final stage of the data lifecycle, sharing it. First, I'd like to draw your attention to this real legitimate chart that was used by ABC about what worries people about COVID. There are so many fun things going on with this chart. There's a color scheme that is 3 shades apart, and obviously there's this pie chart that somehow adds up to 178%. I love extra pi, but there's just so many things with this visualization that it's quite surprising that that ABC channel shared this out actually. Sharing data is often the part where a lot of inaccuracies and misrepresentations unfortunately show up. In general, people need to be very careful about the story that they're trying to tell and what they want viewers to take away from it. Faulty reporting includes data results that are constructed incorrectly or have typos. In such cases, it starts a whole cycle, since that same faulty data might spur further analysis that is also inaccurate. This could be in the form of reports, data stories, or visualizations. A good practice is to gently remove any data from being shared that doesn't have an active owner. Next thing to worry about is misinterpreted results. When COVID data was initially shared, I saw a lot of examples of charts in publications and online by very reputable sources that honestly could have taken an extra 5 minutes to clearly label their charts. I saw missing keys, labels that were listed hidden inside a paragraph instead of right next to the chart, or things that people would assume to be true about some data that was being represented, and it really wasn't, because there was a caveat that was hidden away in some tiny text. There were also a lot of cases where things were being sensationalized, where the raw numbers looked terrible, or in some cases, maybe they looked great. But when you normalized it by population size or by some other factor, you saw a completely different insight from it. Such misrepresentations can have very, very dire consequences. In healthcare, of course, it shows up in a very interesting way because policymakers and citizens can react to this misinformation, and they may end up focusing on things that are just not the highest priority. And finally, a very common problem at this stage is that once you give people access to some data, they are free to use it however they want in other analyses. Some of the use cases might really not align with what the data represents and is supposed to be used for. And unfortunately, you can't always stop people from doing that. But what you can do is to be thorough and about listing the nuances of the data and giving some documentation that tries its best to ensure that if there are any potential downstream uses, that people understand what it can and cannot be used for. So that wraps up our prevent stage. Once again, remember to keep in mind the various ways it is common to introduce bad data. This is not an exhaustive list, but rather a mind prompt to help folks easily identify the various things that they should keep in mind based on very common observations. So hopefully, once you understand how bad data gets created, it becomes a little easier to diagnose what is exactly going on. There are some very common ways that people notice bad data. So usually data has some source of truth or just something that you trust a lot, and some other data shows up that does not match that either in absolute or in aggregation. So you have some results that just don't seem to match and you don't know why they are misaligned. Other times you see a data result and it just doesn't make sense. It's not logical and you are not sure that it is representing something correct. Sometimes it is indeed the right answer, but having some suspicions about data results is still healthy and it can warrant a few investigations to either prove or disprove what you're thinking about it. Either ways, the first step is to look for the obvious reasons why you're encountering or suspecting bad data. First obvious question to ask is this really bad data? Were those two numbers really supposed to match, or were they always meant to represent different things? What can you learn more about the data that you're seeing, which can help you understand why that discrepancy might be there? And if there was a suspicious result, what assumptions have led you to those suspicions? And as you build on more of these type of assumptions, what do you know to be not true as you keep making these investigations? After that, look at your data set. Was it even built for the use case that you're trying to apply it to? And are you looking for the right answer, but in the wrong places? Finally, is there some known bug or pipeline issue, which means your bad data issue is either temporary or has a known fix that you can dive into? Just asking people to figure out if there are known causes that might be the reason for your bad data can help you figure out what you should do as the next step. If none of the obvious reasons are the answer, then it is time to be methodical and go step by step to find the root cause. Start with the data lifecycle in reverse order. For each phase, verify if the phase before it has the right data. This will help identify exactly where in the life cycle something is breaking. When you find the phase where the data is breaking, go through the common root cause example and create a hypothesis about what might be happening. Hypothesize, test, and validate, and keep repeating that process until you find something that explains your issues fully. Final sanity checklist is to just logically go through your problem and document what you know and what you need to figure out. I go for the journalistic favorite questions of trying to document a story and focus on the what, where, when, why, who, and the how of the problem. As you go through this, it helps to rope in other people to walk through your logic or even look up data dictionaries and other documentation to validate your initial assumptions. The truth is out there. You just have to keep breaking down the problem until you find the specific issue. Once you diagnose bad data, curing it is a lot more straightforward. When you have correctly identified the problem, the solution will be straightforward. The diagnosis will tell you where the problem lies, and it isn't always going to be in your hands to be able to fix it. The data lifecycle has many parts, and any of those parts could have an issue that has multiple owners, all of whom need to come together to fix it. Also, do keep in mind that you can't always fix all the issues for the past. Sometimes something that broke causes a permanent and unfixable gap. However, you can cure it for the future and add guardrails in place to flag issues going forward, and sometimes even catch these issues very early in the pipeline so that you can fix them soon. Here are some of the most basic scripts you can write to fix issues faster, which can result in less data corruption. The more familiar you are with your data and its most common problems, the easier it is going to be to write common scripts or even make visualizations that can make it easy for you to quickly pinpoint and fix problems. A basic volume check across different sources to see if you are inconsistent with the rows of the data, or if what is or isn't in those rows is what is causing the problem, can be one start. There can be things that help you quickly identify missing data, or the data that is duplicate is also very useful to quickly narrow down what it is that you need to fix. And finally, just being able to break down the data by different dimensions can be really helpful especially when the data that you're dealing with is very large and small volume changes aren't noticeable. You may realize that in general, your data looks fine, but there is this one whole disease area that had corrupt data type due to a typo, or a certain drug type that had too many ingredients or something like that, that ends up breaking some backend automation that you were trying to do. Here are some coding practices that can help you stay consistent. First up, create reusable modules. You will thank your past self when you're in a time crunch and need to quickly check a bunch of things in a very short amount of time. Next up, document well and centralize your code to make it accessible across your team, which helps build consistency. That documentation is helpful to you as well when you relook at your code at a later date. And finally, add alerts to your pipeline. Over time, you should have a very good idea of what thresholds are normal and what numbers showing up should immediately cause you to launch an investigation. Last reminder, prevention is always better than cure. There is the more detailed data lifecycle checklist that can help you look at each phase and also find ways of preventing bad data. And there are also some other generalized strategies that I've listed here that can help you early on. For example, reconcile your terminologies, make sure everybody in your company is speaking the same language. A lot of times people just make assumptions based on what they think the other person is talking about, and that can lead to a lot of inconsistencies that somehow end up showing up in your data. Also try to automate everything. It helps you don't have to do it again, and simplification of things like curated data sets so that everybody is using the same sources, everybody is reconciled on their methodology, can really be very helpful. Making sure you have a governance strategy that has been created early can also help you save a lot of headache at a later stage. And there is a threshold in your company at which you should be actively thinking about creating these governance strategies. Also, at regular intervals, try to do an audit and figure out what strategies and processes are working for you. Have a way for folks to flag inconsistencies or stuff that is broken so that those things actively get addressed and are not consistently thrown off for a future fix. And with that, I wanted to leave you all with some additional research and reference material. There are some things listed here which I found them to be very helpful, but I also have a few more specific coding examples in one of my other talks that is linked on my website as well. So do check it out if you have the time and if you're interested. Thank you all so much for attending today's keynote. Dealing with bad data can be frustrating for everyone involved, but with the right mindset and the right frameworks, hopefully it becomes a little more manageable. I really hope you found the content useful. If you have some questions, comments, or stories to share at this point, I would love to hear them. Think about the type of issues that take up a lot of your unnecessary time. Which ones would you like to tackle first going forward? If you'd like to connect with me after the conference, I'm very active on Twitter. I regularly post a lot of resources on both Twitter and LinkedIn, which you can access if you follow me in either place. You can also find some additional ways of getting in touch with me on my website, shailvi.com. I put out a lot of free content and offer mentorship for women in tech, folks who are new engineering managers, and anyone who is looking for some guidance in the data and tech world. Lastly, I am really grateful to the Women in Data Science Miami team for organizing this wonderful event and for hosting me virtually. This is a wonderful community of very dedicated folks, and I am so glad to be a part of this. I hope you all enjoy the rest of the amazing content today and build connections with others in the industry. Thank you all and have a wonderful day.